And welcome back to my new video. In the previous video, I explained to you about chi-square. I also talked about statistical significance, what different levels of statistical significance mean, and how to perform a chi-square test on PSPP. So now we're going to be talking about ANOVA, or specifically speaking, one-way analysis of variance. But before performing the ANOVA test, you need to understand what ANOVA actually is. So for this, I've created this small example, which may be helpful. So here we have three different food types. One is the chips, then you have burger, and then you have a healthy meal. And then we have five people in each group, okay, consuming these respective foods. And these are the exact minutes after which each person felt hungry after consuming these foods. So for example, in the chips group, the first person felt hungry after 12 minutes after consuming the chips. The other person felt hungry again after 14 minutes. Then the other one 18 minutes, 16 minutes, and 15 minutes, and so on. In the burger camp, you see the person felt hungry after 25 minutes after consuming the burger. The second person 26 minutes, 28 minutes, the fourth one 27 minutes, and 29, and so on. In the last group, you see the healthy meal group. You see the first person felt hungry after 45 minutes after consuming the healthy meal. The second one 50 minutes, and so on. So here you can see a clear difference between the three groups, right? So there is a variance, okay, between the three groups in terms of the time it took for them to feel hungry again. So the chips group clearly, as you can see from the numbers, the people who ate chips felt hungrier much earlier than the people who consumed the burger and the healthy meal. And the people who consumed the healthy meal felt satiated for a much longer period of time. So that's what analysis of variance tries to find out, whether there is any statistically significant variation between the groups. So these are the three groups: the chips, the burger, and the healthy meal. Yeah, we want to know whether the type of food that the person consumes has an impact on how quickly they feel hungry again. In other words, does the food make an impact? You know, so that's what the analysis of variance basically does. The formula is like F is equal to the variance between groups divided by variance within groups. And the greater the ratio or the larger the ratio, the more likely is the fact that the type of food in this case plays a role in determining how quickly they feel hungry. Yeah. So we want to know whether the type of food has an impact on how quickly they feel hungry. That's what, in this particular case, ANOVA will help us find out. In the next part of the video, I will show you how to perform ANOVA on PSPP using a sample data. And in the previous part of the video, we talked about the theoretical concept of ANOVA. Now we're going to use the sample data to actually perform the ANOVA test on PSPP. But before that, I just wanted to add that in this particular example, you have one categorical variable and one continuous variable. So what's a categorical variable? The categorical variable is nothing but the food, you know. So when you say categorical, that means they're in categories. So food can only be in categories. You have chips, your burger, and then you have the healthy meal. On the other hand, you have another one, which is the continuous variable. So the continuous variable here is time. So the time taken for each individual to feel hungry again. So 12 minutes, 14 minutes, 25 minutes. This is a continuous variable. Continuous variables are usually in running numbers. So in ANOVA, unlike in chi-square, what we do is we have two categorical variables. We want to find out whether there's an association between two categorical variables. Okay, but here in ANOVA, we have one categorical variable and one continuous variable. In one-way ANOVA, that is, we have one categorical variable and one continuous variable. So when you have data that's in such a nature, performing a one-way analysis of variance is a wise move. Okay. Now we'll go back to the data that we have. So this particular data is a common data that I usually use for these kinds of videos. This data is actually on cancer patients. You might have seen this data. I've used it previously, as I said. And this is on the mental health, basically the depression, anxiety, and stress of cancer patients. Yeah. So here there are several variables here. So we want one categorical variable and one continuous variable. So when you look at the variable view, there's one variable called marital status. So the marital status is a categorical variable. Okay, so just like here you had the different foods, that's the categorical variable. here you have marital status. There are three groups here. One is the unmarried, the second one is the married, and the third one is the divorced and or separated. Yeah, so there are people who've been grouped into these three. Yeah, so that's the categorical variable, and the purpose of this ANOVA test is to find out which among these three groups of people are more depressed, and whether being in one of these three groups plays a role in determining how depressed you are. Meaning that whether you being married or unmarried or divorced has a role to play in your depression score. That's what the ANOVA test basically will help us uncover. The depression score is continuous in nature. While the marital status is a categorical variable, the depression score that we're going to use is continuous in nature. It's a running numbers. Yeah, right. So let's go and perform the ANOVA test, the one-way analysis of variance. Go to Analyze, Compare Means, One-way ANOVA. Yeah, and then in the factor column, we put in marital status. Yeah, and in the dependent variable column, we put the total depression score, which we have already calculated. It's it's there, and then we click on descriptives. Okay, so then you click OK, and that's it. So here you can see the three different groups: unmarried, married, and divorced and separated. So unlike in that example where we used when we looked at individual scores, here we have the mean score. Yeah, that's the only difference. So mean score is the average score of the respondents with regard to depression among the three different groups. So the unmarried people, on an average, their score is, or the mean score rather, is 26.15. So the mean score of the married people with regard to depression, anxiety, with regard to depression is 13.65, and for the divorced and separated, it's 19. Yeah. So the average score, as you can see, there is a difference. There is a difference between these three. But does being in these three different groups play a role in determining a depression score? For example, does being unmarried have a role, or married or divorced play a role in determining a depression score? That's what the ANOVA test shows you, and we have calculated the significance for that. The significance value here is 0.005, which means 0.5% chance of error, or 99.95% of accuracy. So in other words, this result is statistically significant at 0.01 level. Okay, so to understand and interpret significance level, you can watch my previous video on chi-square. So the point here is that so if you look at the mean score, it gives you a clearer picture. You see that the unmarried people have the highest depression score. So they are the one which have the higher mean score of depression. It's 26. This is followed by those who are divorced and separated. They are quite depressed too. But then the married people, the one have the lowest score of depression. They are the least depressed. It's important to remember that this data is among the cancer patients. So when you are in a tragic situation like being diagnosed with cancer, being in a married camp is a good idea. You'll have a less depression score based on this data. So that's what it shows. So the marital status plays an important role in your depression score, and the results are statistically significant at 0.01 level. Okay, so now in the next part of the video, I'll tell you how to interpret and explain this particular result. Yeah. So now I've actually created a table, and then I've explained the results that we found here. So in this particular case, you can see I've created a table where you have the marital status. You have the N, which shows the number of observations, the number of respondents. Then you have the mean score of depression of the respondents. You have F, the F statistic, and then you have significance. Now, what is the F statistic? The F statistics is what we use to find out whether there is a significance or not. Okay, so that's all you need to know. The F statistics is calculated automatically by the computer, and based on that, you get the significance value which we interpret. Now, in this case, you have this explanation that I've given. The results in table 1 indicate the fact that in the present study, those who are unmarried have the highest mean score of depression. So they are 26.15, I've written it in the bracket, among the different groups. This is followed by those who are divorced or separated, 19.00. Finally, those who are married have the least score of depression, which is 13.65 among the different groups. So when you compare these three different groups, they have the lowest. So that's what I'm trying to say here. Moreover, the results of the one-way analysis of variance, or ANOVA, indicate the fact that there is a statistically significant difference in the mean score of depression of the respondents across marital status at a high level. Okay, so that's a bit tricky to understand, but it's quite simple actually. So I'm repeating that again. Moreover, the results of the one-way analysis of variance, that is the ANOVA test, indicate the fact that there is a statistically significant difference. So we are telling there is a difference between there is a statistically significant difference in the mean score of depression of the respondents across their marital status. Yeah, so we see the difference there, and that is at a high level. So p is less than 0.01. So when the p is less than 0.01, we usually use the term high level. Yeah, so that's the significance value here. Finally, we use one line we say, thus the null hypothesis is rejected in this regard. So the null hypothesis would be something like there is no statistically significant difference in the mean score of depression of the respondents across marital status. So that is a null hypothesis. So this result shows that we can reject the null hypothesis, that there is a statistically significant difference in this regard. So that's it for this video. I hope you understood ANOVA. Yeah, and if you have any doubts or any confusions, you can just leave a comment in the comment section. For more videos, just like and subscribe to my channel. It keeps me motivated to make more videos. Yeah, thanks a lot for watching. Bye for now.